Okay. So the target here for this section is going to be to generalize rules about horizontal asymptotes. Okay. So we have three different possibilities that can occur. Possibility is A is that g of x, which is the denominator, the bottom, grows faster or is our dominant term. So if I have something on the top that's small over something big, right? If this is our dominant term, this is big term is going to pull it down until it's worth nothing. So we're going to look at a couple examples here in a minute, but for now, it's going to pull it to 0. All right, let's come down here to this bottom one. If they grow at the same rate, so I have small over small, or big over big, or medium over medium, then they're going to create a number, some kind of term or a specific output that it's focusing in on. So this number right here will be the coefficient of the dominant term divided by the coefficient of the dominant term. So this will be dominant term of the numerator and the denominator. Okay. And then this one here is that if the numerator is our bigger term, so I have something big divided by something small, the big term is going to outweigh this guy so much that it's going to pull it up, 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 up if you're going to the right, or it could possibly pull it down, 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 like a really big negative number would pull it down. So this can go to positive infinity, or it can go to negative infinity. So those are a couple of our options for this center guy. So 3 different scenarios. If I have a small number divided by a big number, we're going to 0. Big by small, we're going to infinity or positive or negative infinity. And if they're worth the same, we're going to end up with a number. Okay, we're going to look at some examples of that one. So let's look at number 4 here together. And then you're going to do these independently as practice. So the first thing we're going to do is we're going to circle, whoops, in the numerator. And in the denominator. Our dominant terms. I can't speak today. So 5x squared over negative 11x squared. So are they the same? Are they different? Or are they, I'm sorry, by different, do I mean bigger here or bigger here? Well, this one's the same, both the top and the bottom. So if I were to write that out, these two would cancel out. No matter how big they get or how small they are, they're going to be worth the same amount. So this is going to be 5 over negative 11. Okay. So I want you to do 5, 6, 7, and 8 as a practice. And then what I want you to do here is to write some directions or a sentence to yourself telling you what you have to do, what must you do with a function that has more than one term. So like these guys up here, they have more than one term. They have 1, 2, 3 terms that make up the whole numerator. So what do I need to do before I'm allowed to work on its limitations? Okay. We'll be able to get through 2 pages maybe on this video. So this video's target is going to be going over limits at positive or negative infinity to talk about horizontal asymptotes of functions. So we're going to look at analytical differences, how that's different in finding a vertical asymptote and finding a horizontal asymptote. So we're going to look at these 6 examples, and we're going to look at whether or not they're dealing with horizontal or vertical. So some terminology here. Horizontal asymptote, the line y equals L, where L is some number, is called a horizontal asymptote of the curve y equals f of x. So this is our original function. Original function. If the limit going to the right approaches a number, or if the limit going to the left approaches a number. And most of these examples we're going to look at in rational functions are going to do this. They'll either go to a number or they'll go to 0, which is also a number. But these ones, the ones that are more difficult, are the ones where it's approaching a number other than 0. Okay, so we're going to look at our asymptotes. We're going to color coordinate. So it looks like we've got one here. It looks like we've got one here. And it looks like we've got one here. So those are the 3 places it looks like we've got some difficulties going on in our function. So let's go ahead and look at what these guys' output are going to be. So as x approaches -2 with a little plus sign, that means from the right. What is my function doing? So -2, that must be this one that's navy blue over here. That's this guy. So if I'm coming at it from the right, I take my finger or my pen or whatever, and I'm tracing the function as it goes towards -2 from the right. What's it doing? It's going down really, really fast. So it means this guy is approaching -infinity. As we come at it from the right, tracing, 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 look, it shoots off to +infinity. So I'm tracing along and whoop, up and away it goes. So that's +infinity. Okay, x approaches +4. That must be this guy right here. So it doesn't have a plus or a minus on it, so we're going to need to come over here and break it up into that so that we can decide if this even exists, if I'm able to describe what's happening as the function goes towards 4 from both sides. So x approaches 4 from the right, and x approaches 4 from the left. So as it approaches it from the right, tracing along with my pen, what's it doing? It's going up, 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 up. So the function is going up to +infinity. As I trace along from the left side, it's going down, -infinity. So this goes back to our earlier idea that I can only describe the limit as x approaches a specific number if it is occurring in the same way on both the left and the right. So I can't say that as the function comes at 4, it's going up. I can't say that it's going down because it's doing both. It's doing one thing from the right and one thing from the left. So there's not one way that I can describe the function coming towards the number 4 because it does 2 different things. Okay. So what I would say there, I'll let this refocus for a second. So what I would say there is that there's no way to describe that, so it does not exist. Now, the limit as x approaches +infinity, so as I trace my function as it's going out towards the right, what is it doing? Well, it appears to be getting closer and closer and closer to 0, so we're just going to estimate for this function and say it's approaching 0. And as it is going to -infinity, so I drag my pen out to the left, it also looks like it's probably going down towards 0. So let's say 0. So now we're going to write the equation of the asymptotes. So the purple line is a line where y will always equal 0. The turquoise line is the line where x always equals 4. And the navy blue line is the line where x always equals -2. Okay. Let's look at an example of type 2. So we're going to look at some different ones. Here we went from a graph and talking about limits. Now here we're going to go from function and we're going to talk about limits of different things. So let's talk about the different functions. So vertical asymptotes. Vertical asymptotes are caused by issues in the domain. So what are our issues in the domain? Well, if I look up here, I know that x equals 5 is a domain issue. So I'm going to check to see if it gives me a whole or a vertical asymptote. Now, it'll be a whole if I get 0 over 0, and I'll have to figure out how to fix that. And vertical asymptote if I get some kind of number. Any number other than 0 over 0 is indicative of a vertical asymptote. So let's plug it in. F of the excluded value, 5, is going to be 3 times 5 over 5 minus 5, which is 15 over 0. So this is telling us that we have a vertical asymptote at x equals 5. So 1, 2, 3, 4, 5. Got a vertical asymptote. Now let's check our horizontal asymptotes. So I rewrite it with only our dominant terms. So we'll be left with 3x over x, which is going to simplify to just 3 over 1. That means we have a horizontal asymptote at 3. So the first thing that I do when I'm graphing rational functions is I note where these are occurring. Okay, so I've got my horizontal in there in purple and my vertical in there in navy blue. And I'm going to close the window, see if I can get it to get a little bit clearer. And now I'm going to approach my vertical asymptote from the left and from the right and see what my function does. So we're going to do some graphic analysis. So we're going to say the limit, so what is my function doing in a general sense as x approaches this 5 from the right, and what is it doing as x approaches 5 from the left. Okay. So from the right, let's put in a number that would be slightly bigger than 5. So we're going to say 3 times 5.001. That's fine. That's slightly bigger. It's not too slight. It's a little bit, it's not huge difference, but it's pretty small. Close enough. So x would be 5.001 minus 5. So this is going to give us a little bit more than 15 over something really, really tiny, 001. So I've got a big number over a really small number, which means that as we're coming at this towards the right, we're going up like that. The limit as we come at it from the left, we're going to have 3 times, let's do 4.999 over 4.999 minus 5. So this is going to give us, again, slightly less. We're going to go approximately 15 divided by negative 0.00001. So now we have a big number divided by a small negative number, which means this is going to go down to negative infinity. Now because my horizontal asymptote is up here, this line is going to have to go across the x-axis, and so we could calculate that by plugging in y equals 0 and solving. We'll do that more at a later date. And it's also going to pass through the y-axis. So we could calculate both our x-axis and our y-axis intercept. But for now, we're just going to kind of eyeball it. So it's going to go off that way, and it's going to go off that way. If I wanted to, I could do the limit as x approaches infinity. I would get 3 infinities over 1 infinity. I could also plug in something like 1,000,000. What would I get? 3,000,000 divided by 1,000,000. That's still basically just 3. So this is going to come closer and closer and closer to 3 as this number gets bigger and bigger. The limit as x approaches negative infinity would be 3 times negative infinity over 1 times negative infinity, and that's going to get us still about 3. So this guy's going to be coming from 3, coming towards 3. So what I want you to do is to try this one and this one, calculate the vertical, calculate the horizontal, and then we're going to check for holes. Okay. We'll come back and we'll look at those more in class.
You guys want to give this to some of your students?
Yes.
Oh God. Are you nominating